Okay, so inscribed angle. So we're going to do these problem types. This is actually from your study guide, and you don't have to do the study guide obviously anymore, but we're going to use this study guide as a source of problem types for inscribed angles. So let's first talk about what are inscribed angles. So if you have a circle, there are two types of angles that we're going to be dealing with. Okay, so here's a circle. Okay, now a central angle is called a central angle because it involves the center of the circle. Now, the relationship between the central angle and the arc measure being the amount of curve of the arc, is that the central angle, the measure of the central angle and the measure of the arc is the same. So for example, if this is, say, 80 degrees, then the arc measure is also 80 degrees. Okay, it's a one-to-one relationship. Now, this is in contrast to an inscribed angle. An inscribed angle is an angle whose vertex is actually on the edge of the circle. So does everyone see the difference between a central angle and an inscribed angle? Now, say for example, this is 60 degrees, okay? So the measure of the angle is 60 degrees. The relationship between the arc and the angle, okay? The relationship between the inscribed arc and the inscribed angle and its intercepted arc, the arc that it is associated with, is that the arc is double the angle. So if the inscribed angle is 60 degrees, the arc is double that, which is 120. 120. And likewise, if I gave you just the arc is 120 degrees, then the inscribed angle will be half that, which is 60 degrees. So central angle and arc, same measurement. Inscribed angle and arc, the angle is half the arc, or the arc is double the angle. And that's fundamentally the main take-home point, all right? Now, let's see how I'm going to ask you, how they can ask you this. So let's look at number one, okay? So we want to find, they're asking you to find the measurement of this angle right here. And since it's on the edge, it is known as an inscribed angle. So what you want to do is say, okay, well, what's the relationship between this angle and the arc? Well, this is the associated arc right here. And the arc is 98 degrees. So what does that make the angle?
Um, 49.
49, good. Okay. Now, let's see here. All right, let's look at this.
How would that be 49?
Okay, so what is the arc measure?
98.
Okay, so how is the arc and the angle related? We just talked about that. So the inscribed angle is equal to 1/2 the arc, or the arc is double the inscribed angle. So if the arc is 98, to find the angle, you take half of the arc, which is 49. 98 divided by 2 is 49. Okay.
Thank you.
Now, let's look at number 3. asked to find this angle. So what's the arc that it has? Well, this is the angle, and this is where like colored pencils and pens come into play. This is the associated arc. And the associated arc is 60 plus 62, which is?
122.
Okay. So what does that make the angle?
$61.
Good. Make sense?
Yeah.
Okay.
Yes.
Now, let's look at a problem like this, number 4. Okay. Angle R is an inscribed angle. Okay. And you're asked to find the measurement of WXY. So you're asked to find the measurement of this arc. Okay. So the inscribed angle is 105. What does that make the arc?
$210.
Okay. So let me ask you a question. What does that make X? How can we figure that out based on this diagram?
360 minus 210.
Right, because remember in a full circle is 360 degrees. So from here to here is 210. So that means whatever's left is 360 minus 210, which is 150. So what does that make X?
$7.5. No, sorry, I did it wrong. 75.
Everyone understand how we did that? Now, look at this quadrilateral, WXY and R, okay? WXYR. That is an inscribed polygon because all of its vertices are on the circle, okay? Now, look at angle X and angle R. What does angle X plus angle R equal? If I add the measurement of angle X plus measurement of angle R, what do I get?
Oh, 180.
180. What do we call angles that add up to 180?
Supplementary.
Supplementary. And that's another one of the theorems. We actually went through this theorem before we adjourned for the COVID break, if you will. If you have an inscribed polygon, that means all the vertices are on the circle. Opposite angles are supplementary. So like if you see here, R and X are opposite angles, and they are supplementary. Well, W and Y are also opposite angles, so they will also be supplementary. That means they add up to 180. Okay, and that's one of your theorems, that in an inscribed polygon or an inscribed quadrilateral, opposite angles are supplementary. In an inscribed quadrilateral, opposite angles are supplementary. So if you knew that theorem, then you could easily figure out what X was. This was 105, and X is opposite R, so it's a supplementary, so it'll be 75. Any questions? Are we good with this? Okay. So what do we get for number 2?
That would be 180 minus 66, right?
Because they're opposite angles. So what do we get for M?
140.
1/14, yeah. Okay. Right, so let's look at number 5. Let's have you guys try to do number 5.
So it's 40 for angle F.
Yes.
Okay.
Well, not the entire angle F, this little piece right here.
All right. I don't even know where to start.
Okay, so you're going to have to walk around the circle, if you will. We know this angle is 40, right?
Yes.
So draw out the angle and see the arc that it is associated with. Okay, so what is the associated intersected arc?
RH.
RH. So if the angle is 40, what does that? If the angle is 40, what does that make the arc?
Oh, 80.
80.
And so the other arc would be 100, right?
How'd you get it?
Because H and F
Mm-hmm.
is the diameter,
Mm-hmm.
and it makes semicircle, and semicircle is 180 degrees.
Right. So this is an entire semicircle right here. From H all the way to F is a semicircle. How do I know this is a semicircle?
Because it's half a circle.
Yeah, well, look at this line. What do we call this line right here? What do we call line HF?
Diameter.
The diameter. How do I know it's a diameter?
Because two radii put together.
Yeah, and it goes through the center. So remember,
Yeah.
a chord that goes through the center of the circle is a diameter. So if this is the diameter, that means from this edge to this edge on the curve is a semicircle. So that means if a full circle is 360, a semicircle being half a circle is 180. So we found out from this problem, from the diagram, that this portion of the semicircle is 80. That means the other portion is 100. Okay. So this is the thing that you're going to have to be doing. Okay. This is what you're going to sort of have to do with these types of problems. Look at the diagram. Look at what information has been given to you. Draw out your angles and see the associated arcs and fill in as needed until you get the information that you need. All right. Number 6. Let's do number 6.
It'd be 180 minus 62,
Okay.
which is 118, and then
So
half
what is
the
118?
TD, arc
Okay.
TD.
So the arc TD is 118.
And you divide it by 2 because the angle is half the arc, and it's 59.
Good. Perfect. Any questions? Are you getting it, Ms. Sizemore?
Yeah.
Okay. Now, let's talk about another theorem. Let's say, for example, I have a circle. Okay. And this is center. We actually talked about this right before we left. What is the measurement of this angle?
Be 90
How'd you get that?
because of the second corollary theorem or something.
Mm-hmm. Okay, so if you did not know the theorem, we know that from here all the way to here is 180 degrees because this is semicircle. Well, if this is 180, the inscribed angle that is associated with this arc has to be 90. And what do we call an angle that is 90 degrees?
Right triangle.
Right angle, yeah.
Or yeah,
So
right.
this is the next theorem, okay? This is another theorem that's pretty important. If you have a triangle inscribed within a semicircle, so you have a triangle here, and it's inscribed because all three of its vertices are on the circle, okay? And it's inscribed within a semicircle because one side of it is a diameter. Then we know that this angle is 90 degrees, okay? And that is one of your other theorems. So a triangle inscribed within a semicircle is a right triangle. And this opens up a host of problem types that are pretty interesting. So normally when I was giving you right triangle problems, I told you you cannot assume that the triangle is right until I show you that little box. But that doesn't have to be the case anymore when I'm dealing with circles, diagrams of circles. All I have to do is give you a diagram like this. And say, what's the radius of circle O?
Radius.
Yeah, what is the radius of circle P?
$34.
That's not the radius.
Oh no, sorry. It's 17
How'd you get it?
because you have to do Pythagorean theorem. So you
Right.
use 16 squared plus 30 squared, and then you get 34 squared.
Okay.
Yeah, 34 squared,
Mm-hmm.
and then half 34 is 17.
Okay. And why can we use the Pythagorean theorem? Well, because remember, Pythagorean theorem we can only use with a right triangle. And that's the thing. I told you before that you cannot assume a triangle is right unless you see a little square at one of the angles. But this is a triangle within a semicircle. So I don't have to draw the square. You have to know that, okay, well, this is a triangle inscribed within a semicircle. Therefore, this is by default a right triangle, even though I did not put this box here. So once you know it's a right triangle, you can use the Pythagorean theorem. Use the Pythagorean theorem to find the diameter, which is 34. Therefore, the radius is half that, which is 17. Okay. So take home point, if you see a triangle inscribed within a semicircle, it is safe to assume that it is a right triangle. And so all properties of right triangles apply to triangles inscribed within a semicircle. Does that make sense to everybody?
Yeah.
Yes, sir.
Okay. So let's look at a couple of problems. Okay. Let's do number 11. Let's start off easy. Let's do number 11. Like a warm-up, if you will. We're solving for x.
The angle
Yeah, we're
would
solving
50.
for x. What is x here?
$15.
How'd you get it?
Half the arc is 50, and so you do 20 plus 2x equals 50.
Okay, so if this is 100, that means this angle is 50 degrees because it's half the arc. So 20 plus 2x equals 50. 2x equals 30. X is 15. Are we good with that?
Mm-hmm.
Okay. All right. Let's do number 12. Solve for x. Okay, I want somebody else to pipe in besides Miss Sizemore. There's so many other people here, so please speak up. Make sure to unmute yourself. How do we solve for x here? What would be my equation that I would write first in order to solve for x?
Pythagorean theorem?
Not Pythagorean theorem. We're not asking for a side. We're given that this arc right here is 24x minus 4, and we're given that this arc adjacent to it is 23x minus 4.
Would you set it both of them equal to 180?
Yeah, because remember, this is a semicircle, right?
Yeah.
Okay, and I know because it's going through the center of the circle. This is the diameter. Okay, so this arc, 24x minus 4, plus the other arc, 23x minus 4, have to equal 180. Okay, then it's just a matter of doing your algebra. Make sense?
Yep.
Yes,
Okay.
sir.
Mhm. Okay, I want you guys to look at number 15. See what y'all can do with number 15. This is the type of problems that you're going to get quite a frequent amount of. Something that really requires a critical approach. Okay.
What do you do?
Okay, well, let's talk about it. In order for me to find this angle, that's what I'm looking for, I need to know what x is. Does everyone see that? In order to find what the measurement of this angle is, I need to first know what x is. Now, how do I find x? Well, what is the relationship that this angle has in relationship to the intersected arc? What's the relationship between the angle angle G and the arc DEG?
G is half of the arc.
Right. DEG is half of the angle. I mean, double the angle, or the angle is 1/2 the arc. So if G is 61x minus 1, what expression can I write for arc DEG?
Would you multiply it by 2?
Right. So arc DEG is 2 times the angle. Okay. Now, if DEG, let's go ahead and distribute it, is 122x minus 2, and DG is 96, and GF is 144x, what is the expression that I can write?
Well, if you're only finding that one arc, you don't need the other ones, do you?
Well, you don't need it, but you need to be able to write an equation in which you need to, so you can solve for x. And there is an equation that I can write. Now that I know that this arc is 122x minus 2, and I know this portion of it, of the circle, is 96, and I know this portion of it is 144x, what is the expression that I can write?
You add those together and then equal it to 360.
Right, because remember, in a full circle, it's 360. So 144x plus 122x minus 2 plus 96 equals 360. Then it's just a matter of combining all of your terms and solving like you normally would. So 266x plus 94 equals 360. Oops.
Zero.
X is 0.
Oh, 1. Yeah, sorry, it's 1.
So if x is 1, what does that make? Does that answer my question? Is that what I'm looking for? Am I looking for x? Is that what the question's asking me?
No.
No. What is the question asking me?
Find the measure of DGF.
Okay. So What is DGF? Now that we know x is 1, what does that make DGF?
60.
Right. So remember, before we left, I said that the previous circle test that you had was actually the easier of the two circle tests that you're going to have. And this test, with all the circles and stuff, is going to be a little bit more complicated. And this is why. Because it requires you to really hone in on that diagram and concentrate and see what it's giving you and use the information to write other expressions and stuff like that. Any questions on this? Any questions on how I approached it?
How did we get 60?
Okay, so did you see how I got x equals 1?
Yes.
Okay, so I'm looking for this angle right here. Okay, the angle, the formula for the angle is 61x minus 1. Well, we found out that x is 1, so we plug it in. 61 times 1 minus 1, which is 61, which is 60. Make sense?
Yes, sir. Thank you.
Right. Let's have you guys do number 18. Okay, so what do we do?
You find the arc CBW because the arc is double the angle D, and you would get 8x plus 36.
Everyone on the same page is how we got 8x plus 36, okay? So this angle is 4x plus 18, so if we double it, we get 8x plus 36, okay? So 8x, that is 8x plus 36. If that portion is 8x plus 36, this portion is 88, and the rest of it is 10x plus 20. What would be my equation?
10x plus 20 plus 88 plus 8x plus 36 equals 360.
Okay. Then all you have to do is do your algebra, combine like terms, and 108 plus 36 is what, 144. Now, x is 12, so what does that make CD?
140.
$140?
X is 12,
Oh,
not
sorry.
18.
Sorry. My brain isn't working this morning. No coffee. Sorry. Any questions? So does everyone feel that they can do well on the inscribed angle quiz? Now,
Yes, sir.
okay, so a couple of things to remember. Take home points. Number one, inscribed angle and the intercepted arc, they have a relationship. The arc is double the angle, or another way of saying that is that the angle is half the arc. Number two, opposite angles of inscribed polygons are supplementary. Okay. Opposite angles of inscribed quadrilaterals are supplementary. And number three, triangles inscribed within a semicircle are right triangles. All right. Any questions?
Nope.
All right, so if that's it, then we will pick up from here tomorrow. We're going to start talking about secants and tangents and stuff like that. And we might actually go into that this afternoon if you want to join this afternoon, depending on how many questions they have about inscribed angles in the afternoon session. All right. Any questions?
No, sir.
All right, well, if there's no more, so y'all have a great rest of your day. And if I see you this afternoon, that's great. And if not, I'll see y'all tomorrow.
Bye. Thank you.
Uh-huh.
Thank you.
Have a nice afternoon, guys.